Hey guys, this video is for part 1 of page 39 about performing calculations with chemical reactions. So this is the beginning of a unit on what we call stoichiometry in chemistry. And stoichiometry is the calculation of relative quantities of reactants and products in chemical reactions. And you can probably tell just from that it's going to relate heavily to our previous unit on chemical reactions and specifically chemical equations. So in fact, in order to perform these calculations, we must have a balanced chemical equation. We're going to look at three different types of stoichiometric calculations. The first is a mole-to-mole calculation, and these are the simplest. So these are calculations in which we compare the number of moles of reactants to the number of moles of product. And the key conversion factor that we're going to need is the mole-to-mole ratio. And we get this from the balanced chemical equation. So when we do our example here on the left, we're going to be looking for the mole-to-mole ratio. So the example for a mole-to-mole calculation here says given the following chemical equation, 2KClO3 produces 2KCl plus 3O2, how many moles of O2 can be produced by letting 12 moles of KClO3 react? So this is a decomposition reaction with a single reactant, and that's KClO3. We're going to start with our given, 12 moles of KClO3, and we want to know how many moles of O2 can that produce. And we use the balanced chemical equation and the mole ratio in it because we know that for every 2 moles of KClO3, we can produce 3 moles of O2. So for every 2 moles of KClO3, we can produce 3 moles of O2. If we multiply and divide, this will tell us how many moles of O2 we can produce with 12 moles. So 12 times 3 divided by 2, we end up getting 18.00 moles of O2. So that's an example of a mole-to-mole calculation.